Bismillah. Hello everyone, this is Gamal from your channel Think Math. Today we are going to talk about composite and inverse functions. So what are composite and inverse functions? Suppose that you have an apple and you want to slice it, and you want also to put it in a bag. So you can first slice it and then put it in a bag. And you can put it in a bag and then slice it, which is not a very practical thing to do, but this is just an example. So what we did here is doing something what we call in math is a composite function. So what is a composite function? A composite function is when you apply a function to a variable and then apply another function to the output of this first function. For example, if we have two functions, f of x equals 2x plus 2, and we have another function, g of x equals x squared. So a composite function would be f of g of x. So we are applying f to the function g instead of applying it to the variable itself. For example, how can we do this now? We have x squared, right? And then we apply f to x squared. So instead of having the variable x here in f, we replace it with the output of the function g, which is x squared. So we do this f of g of x, it would be f of x squared. So it's going to be 2x squared plus 2, which is f of g of x. It's going to be 2x squared plus 2. We can write it also as f circle g of x or f g of x. Okay, so what happens if we do the opposite? We take g of f of x. We then apply, then in that case we first apply f and then we apply g to the output of f. So f of x is going to be 2x plus 2, and then if we apply g on this, so it's going to be, we take everything and square it, so it's going to be 2x plus 2 all squared. So it's going to be 4x squared plus 8x plus 4. Now you notice that f of g of x is not equal to g of f of x. So the order of the application of functions differs in the final output. And this is what you see in the first example that we made when we first sliced the apple and then put it in the bag. It is totally different from putting the apple as a whole apple in the bag and then slicing it. We can also apply the composition of functions to certain values from the domain of the first function or from the result of the first function. For example, if we trying to get g of f of 2, we apply f of 2 and then we apply g to it. How can we do that? First we get f of 2, which is, as we said, is 2x plus 2, so that's g of 2 times 2 plus 2, so it's going to be g of 2 times 2 is 4 plus 6 is 6, so g of 6. So we apply g to 6, then we square the 6, so it becomes g of 6 equals 36, which is 6 squared. We can call the first function that we apply is, in that case here, f. It's called the inner function. And the second function, g, is the outer function. Okay. There is a condition for the composition of the function, or for the composite function to exist, is that the range of g of x, range of the inner function, in this case f, should be in the domain, yes, has to be in the domain of g of x, so that we can apply it. If this is not the case, then the range of the inner function f of x, so the output that comes from f of x will lie outside the domain of g of x, so we cannot apply g of x to the output of f of x. Let's take another example. If f of x equals x squared and g of x equals x minus 3, find f circle g of 1 and f g of x and g f of x. Okay, first we get f of g of 1, so we apply g of x to 1, so g of 1 equals 1 minus 3, which is equal to negative 2. Then f of negative 2 is going to be negative 2 squared, is going to be equal to 4. Okay, so now g f g of x, it's going to be equal to we'll take x minus 3 and then square it, so it's going to be equal to x squared plus minus 6x plus 9. And g f of x is going to be equal to x squared minus 3. Okay, this is another interesting example. Is if we have f of x plus 1 equals 4x squared plus x, and we need to find the original function, find f of x. How can we do that? We can do this by the means of substitution. Let's substitute x plus 1 equals to y. Okay, then x equals y minus 1, which means that f of y equals 4x squared plus x, which is equal to 4 times y minus 1 all squared plus y minus 1. Okay, so this means that this is equal to 4y squared minus 8y plus 4 plus y minus 1, which is equal to 4y squared minus 7y plus 3. Now to get the function, we replace every y with an x, so f of x is going to be equal to 4x squared minus 7x plus 3. And we now got the function. Let's take a couple more examples. If we have f of x equals x squared plus 1 and g of x equals 3x plus 2, and we need to find g of f of 0 and g of square root of a plus 1 and f circle f of y minus 1. Okay, let's first solve a. So g of f of 0, first we apply f to the 0, so f of 0 is going to be 0 plus 1, which is going to be 1, and g of 1 is going to be equal to 3 times 1 plus 2, 3 times 1 plus 2, so it's going to be equal to 5. B. Okay, now we solve part B. So we get g of square root of a plus 1. So we replace every x and put square root of a plus 1 in its place. So it's going to be equal to 3 times square root of a plus 1 plus 2. So it's going to be equal to 3 square root of a plus 3 plus 2, 3 times square root of a plus 5. G of square root of a plus 1. We apply g to this and take 3 square root of a plus 5 as if it is the instead of every x in the original definition of g of x. So it's going to be g of 3 square root of a plus 5. So it's going to be equal to 3 times 3 square root of a plus 5 plus 2, which is going to be 9 square root of a plus 15 plus 2, or 9 square root of a plus 17. Now let's solve f of y minus 1. Remember that f of x equals x squared plus 1. So let's first okay, let's first solve f of y minus 1. So we remove every x and put x and y minus 1. So y minus 1 whole squared plus 1, which is equal to y squared plus minus y squared minus 2y plus 1. And then we add the 1. So everything is y squared minus 2y plus 2. So now let's get f of y minus 1. So we apply the function x squared plus 1 on this. So we get y squared minus 2y plus 2 in the place of x. So we square it and then add a 1 to it. So squaring this bracket gives us y to the power 4 minus
8y to the power of 3 plus 8y squared minus 8y plus 4 plus 1. So it's going to be equal to y to the power of 4 minus 8y cubed plus 8y squared minus 8y plus 5. Which is equal to y to the power of 4 minus 4y cubed plus 8y squared minus 8y plus 4 plus 1. So it's going to be equal to y to the power of 4 minus 4y cubed plus 8y squared minus 8y plus 5. Now let's talk about inverse functions. We said in the previous video about functions and relations that a function can be inverted only if it is a one-to-one function.
A function can only be inverted if it is a one-to-one function. So what is an inverse of a function, or how can we invert a function? Inverting a function is just simply reversing its effect. For example, if we have f of x equals 2x, then we multiplied every variable x by 2. So to return it to the original function, so f minus 1 of x, this is what we call f minus 1. It's not a power, it's not an exponent, but this is the notation that f minus 1 means that this is the inverse function is going to be equal to x over 2. Because now we are taking the output of the function and returning it to the original one. For example, f of 2 equals 2x, which is equal to 4. Then f minus 1 of 4 is going to be equal to 4 minus 2, which is equal to 2. So to return it to the original value, we took the output and divided it by 2. That's how we inverted its effect. To find the inverse of a function, we simply do this with the following. F of x equals, we simply do the following. We put the function in f of x in the form of y equals f of x equals, for example, x plus 5. Then we write it like that, y equals x plus 5. Then we solve for y, so x equals y minus 5. We solve for x, and we solve for x, so x equals y minus 5. And then we replace every x in the place of y and every y in the place of x. Then y equals x minus 5, and this is going to be f minus 1 of x is going to be equal to x minus 1. Let's take another example. Find the inverse function of f of x equals 1 plus x divided by 5 minus x. Then we first start by setting equals y equals f of x, or we say that y equals 1 plus x divided by 5 minus x. Then we make x the subject and we try to solve for x. we make a cross multiplication, so y times 5 minus x equals 1 plus x, and we expand it, so 5y minus yx equals 1 plus x. And now rearranging we get 5y minus 1, 5y minus 1 equals x plus yx, or 5y minus 1 equals x divided by y plus 1, or solving for x we get x equals 5y minus 1 divided by y plus 1, or we can see that f minus 1 of y equals 5y minus 1 divided by y plus 1. Or if we put x back in its place, in y's place, so f minus 1 of x is equal to 5x minus 1 divided by x plus 1, and this is the inverse function of our original function here. So we get f minus 1 of y equals 5y minus 1 over y plus 1. Or if we replace x in place of y, we get f minus 1 of x equals 5x minus 1 divided by x plus 1, which is the inverse function of our original function here. Now, if we apply this to our previous example of f of x equals 1 plus x over 5 minus x, and f minus 1 of x equals 5x minus 1 over 1 plus x, you get, let's apply f minus 1 first. So if we take f of f minus 1 of x is going to be equal to 1 plus 5x minus 1 divided by 1 plus x over 5 minus 5x minus 1 over 1 plus x, going to be equal to x minus 1 . So let's cancel out. So we are left, sorry, this is plus. So we are left with 6x divided by 6, which is equal to x. If we do the opposite and apply f minus 1 on f, so if we apply f minus 1 of x, sorry, on f of x, we get 5 times 1 plus x over 5 minus x minus 1 divided by 1 plus x over 5 minus x. So this is going to be equal to 5 minus x. So 5 plus 5x minus 5 plus x divided by cancel out, so we get this cancel out, so it's 5x plus x, so it's 6x divided by this cancel out as well, 6, which gives us x. So that's how we proved this relation. Okay, two important properties that we need to mention here is that the two important properties that we need to mention here is that the domain of f minus 1 of x is the range of f of x, and the range of f minus 1 of x is the domain of f of x. And one important note is that not every function has an inverse function, and as we said that only one-to-one functions have inverse functions, but all functions have inverse relations. For example, if f of x equals x squared and its domain is R, so its inverse relation is the square root of x, but it's not a function since it can have two values. For example, the square root of 4 is equal to positive or negative 2. So in that case, it's not, the inverse relation is not